Hello, my name is Mark Segal, and I would like to talk to you about the Airborne Long-Range Multi-Beam Optical Network Device, or ALMAND system. ALMAND is currently under development by Intellisense Systems as part of a Navy SBIR contract. Intellisense Systems Inc. is a leading provider of advanced sensing and display solutions supporting a data continuum from acquisition to visualization. We enhance our hardware with software that adds intelligence to our systems and can turn raw data into useful information for improved decision-making and process automation. We are a technology innovator and advanced systems integrator that solves some of our customers' toughest challenges by designing, developing, and manufacturing solutions that sense, transmit, process, and display information. Our core capabilities include environmental sensors, displays and avionics, and artificial or augmented intelligence software solutions. As a company, we strive to create value for customers by providing a variety of capabilities that improve situational awareness, decision-making capabilities, and safety. We offer both off-the-shelf products and custom development services, with our current products, such as the Micro Weather Station, being developed from SBIR contracts to directly meet the DoD's needs. Headquartered in the South Bay area of Los Angeles, our facilities occupy over 80,000 square feet. Our manufacturing capabilities include electronics fabrication, unit qualification testing, systems integration, and volume production with full quality assurance to serve both government and commercial customers. We have the agility of a small business that can provide timely and innovative solutions to our customers, with the stability of an established corporation that can support the entire technology and product development lifecycle. The ALMAND system is being developed by Intellisense to address the Navy's need for a free space optical communication, or FSOC terminal, with a multi-beam transmit and receive capability that can be deployed on either Group 1, 2, or 3 unmanned aerial systems. The Navy's requirements for such a terminal include being able to transmit data over tens of kilometers at data rates of 1 gigabits per second or higher, and being able to perform link acquisition and tracking without resorting to radio frequency communications or GPS support. It should, of course, have low enough SWaP to support integration with UASs, and ideally cover the entire 360-degree field of view without using a gimbal. Such a communication capability offers great utility in land, sea, and space environments. One specific utility of the ALMAND technology is its ability to provide communication systems with a low probability of interception and detection that can be mounted to small UASs. Furthermore, it can operate in environments where RF communications and GPS support are not available and operates over a significantly longer range than stationary terminals, which are limited to approximately 5 kilometers. ALMAND can be mounted to ships, land vehicles, manned aerial platforms, UASs, and stationary terminals for vehicle-to-vehicle or vehicle-to-base FSOC. Other use cases such as satellite-to-satellite or satellite-to-ground FSOC are also possible. Now, let's talk about the details of ALMAND. It's a full-duplex FSOC transceiver with autonomous target identification, locking, and tracking. It can also automatically reestablish a dropped link, all without requiring a gimbal, GPS, or RF side channel. As mentioned previously, it inherently provides communication with a low probability of interception or detection. Also, to maximize operational life while minimizing cost, ALMAND has no moving parts. Though ALMAND is still under development, we have demonstrated data rates of 949 megabits per second, with negligible packet losses. This speed was limited only by the selection of the components chosen for the prototype. This data rate was achieved at a range of over 47 kilometers in simulated light turbulence and over 17 kilometers in simulated heavy turbulence, based on laboratory tests. Additional features of ALMAND include its modular architecture that supports either 1550 nanometers or 1064 nanometers wavelength operation as desired. These wavelengths help maximize link range in land and maritime environments based on atmospheric transmission windows. To cover a wide field of view without using a gimbal or Risley prisms, Almond uses specialized metamaterial-based optics. As of the current design iteration, the system weighs 16.6 pounds, occupies 1 cubic foot, and can operate for several hours on a single 2-pound battery. While the profile that you see here is fairly boxy, the profile can be adjusted to match the requirements of a specific platform. So, what specifically gives Almond an advantage relative to existing FSOC technologies? First, since its beam acquisition and tracking only requires the FSOC link, there is no problem operating in RF-denied or GPS-denied environments. Second, it uses compact, non-mechanical beam steering to provide a pointing accuracy of 20 microradians over a wide field of view. Almond's specialized hardware and custom software enables it to achieve a bit error rate of 10 to the -9 or better, which enables higher data rates. Its low swap design allows it to be integrated with many potential platforms, and obsolescence issues are mitigated by leveraging commercial components where possible and implementing proven communication standards. When comparing Almond to other state-of-the-art technologies, we can see that while some systems such as DARPA's Faux Neck system offers significantly longer link ranges, this comes at a hefty weight cost, preventing integration with small UASs. On the other side of the spectrum, the NRL's modulating retroreflector lasercom has minimal swap, but offers a much shorter link range. Almond is perhaps most comparable to the Violite Communications MLT20, which offers similar data rates, link ranges, and weight. However, the MLT20 requires GPS or an RF side channel for link acquisition, limiting its utility in RF-denied environments. Thus, Almond offers an ideal balance between swap and range and can operate in any environment. Finally, we note that Almond's higher pointing accuracy allows for laser drift while maintaining the link. In terms of development status, Intellisense is currently fabricating and testing the Gen 2 prototype under the Phase 2 development. The Gen 2 prototype is 47% lighter and consumes 24% less power than the Gen 1 prototype. By the end of Phase 2, we plan on demonstrating the Gen 2 prototype in a relevant environment, including UAS to base FSOC and UAS to UAS FSOC. This will bring the technology to TRL-6. After this demonstration, we will focus on integrating the technology with an initial UAS platform, where we can reach TRL-7 and beyond. With regard to transitioning the technology to the fleet, the next major milestone is demonstrating Almond in a relevant operational environment. We then plan to enhance the prototype during a Phase 2S, including developing a more aerodynamic profile and integrating it with a UAS agreed upon with the Navy. We expect that the first fully productized system will be available in either late 2027 or early 2028, which will be implemented under PMA 263. We also foresee the Almond technology being incorporated as part of Force Design 2030. In terms of its commercialization applications, we note that Almond is relatively platform agnostic. It can support links between mobile or stationary platforms, including air-to-air links between manned and/or unmanned platforms, air-to-surface links between aerial platforms and a ground station, vehicle, or ship, satellite-to-satellite links for satellites in low or medium Earth orbit, satellite-to-surface links for any satellite and an Earth-based node, surface-to-undersea links between ships and underwater vehicles, undersea links between submarines or unmanned undersea vehicles. Specific DoD platforms that Almond can be integrated with include the VBAT, MQ-25 Stingray, MQ-4C Triton, MQ-8C Fire Scout, MQ-9 Reaper, and similar UASs. It can also be integrated with the Skyrunner Mk 3.2 light sport aircraft or any quadcopter, aerostat, or balloon with at least a 20-pound payload capacity. And it can, of course, be integrated with any surface vessel or land vehicle with the capacity to support a transceiver. Since the technology is nearing readiness for integration with DoD platforms, we are currently seeking a commercial partner and other government agencies in preparation for developing a productized device. As far as our transition path for the technology, we plan to develop Almond to TRL 7 or 8, and then transition to low-rate initial production, selling directly to the DoD. We also plan to partner with primes such as Lockheed Martin and Boeing to integrate Almond with their UASs at the factory. After establishing Almond on an initial platform, Intellisense will reach out to other DoD agencies to determine who can benefit from Almond and what platforms can be used. As previously mentioned, we are seeking transition partners and programs of record to sponsor the technology. Thank you for your attention and interest in Intellisense's Almond technology. If you have any further questions and requests, feel free to reach out to our business and technical contacts listed on this slide.